Welcome back everyone. My name is Sagar and we are back here with another video. So today is day 186 of our POTD series and this question name is maximum profit by choosing a subset of intervals. So this is given a media level question and but this is a very straightforward question, right? So first of all we are given an intervals array and that is of n length, right? So this is a 2D array. That means the ith element in this array will be this array. So starting and this p. So that denotes the starting point, ending point, and the profit earned by choosing this ith element. So we have to obviously maximize the profit. So we have to find the maximum for profit one can achieve by choosing a subset of non-overlapping intervals. So we have to choose some particular intervals from this array and we have to maximize the profit. And how can we choose the intervals? So we have to only consider that condition that they should not overlap. So overlap means if a starting time of some interval is this, so this is starting time of our first interval, and this is starting time of our this is ending time of our first interval, and if this is starting time of our second interval, and this is ending time of our second interval. So you can see ending time of our first interval is greater, or we can say starting time of our second interval is less than ending of this. So they are overlapping here in this phase. So that's why we cannot choose both of them. If we have to maximize our profit, either we have to choose this or we have to choose this. So we will just write some algorithm which will tell us what will be our maximum profit. So that is the condition I was saying here. So first of all, n equal to 3. So how can we say that? So first of all, 1 to 7, 1 to 5. So we will just create a number line like we do in our algorithms. So 1, 2, 3, 4, 5. So our first interval is from 1 to 2 and have a profit of 4. So 1 to 2 and have a profit of 4. And after that our second interval is from 1 to 5, 1 to 5 and have a profit of, so it is 1 to 5 and a profit of 7. And our next interval is from 2 to 4, 2 to 4 and have a profit of, I think, 4, right? So how can we say what will be our maximum profit? You can see we can just select these two because they are not overlapping here. Our first interval is ending at 2 and our last interval is starting at 2. So we can choose this. So we can choose both of them, and after adding them, the maximum profit will be 8. So we have to select. How can we select? So first of all, either we can sort that according to our starting time or ending time, and I will just show you both approaches. How can we sort according to our starting time and get the result, and how can we sort according to our ending time and modify our algorithm to get the final result. So first of all, what will be the process? So it is here 1 2. Okay, just a second. So first of all, it is here 1 2 2, and then here it is 1 to 7, 1 to 5. Profit is here 7. Okay, our third interval is from 2 to 4 and the profit is also 4. So how can we select? So these are three intervals and they are sorted according to their starting interval. So first of all, how can we do? Either we can select this interval in our maximum answer or not. So there is approach like select and unselect. So either we can select this interval in our maximum answer or it will not participate in our maximum answer. So we have two approaches here. So first of all, we have 1 2. So there are now two choices. Either we have to select this or we don't have to select this, not select. So this is a simple algorithm of select and non-select approach. And if we are selecting this, the correct answer will be equal to. So what is the profit for 1 and 2? You can see here 4. So the profit is 4 and the next element is 1 to 5. And next we have two elements remaining, 1 to 5 and 2 to 4. So we have two elements here, and if we are not selecting it, so if we are not selecting it, then we still have the maximum answer will be still 0, and we have two elements, 1 to 5 and 2 to 4. And what we have to do now? So first of all, there are these two conditions now. So we are here at these two states, and now what we have to do? First of all, if we selected this, then we will also have to specify that now we don't have to select 1 to 2. That means if there is some interval that is in the range 1 to 2, then we don't have to select this. Then we cannot select this because then it will overlap. So if we are selecting this particular ith interval, then we have to care for this condition that there should be no interval that is from 1 to 2. So what we will do, we will just find the minimum interval starting time that is greater than or equal to n time of this, because then we can say definitely we have to find the minimum starting time of some interval that have its time greater than or equal to ending time of our previous, right? So that's how we can say this is not overlapping, right? So this end time is equal to 2 and it is starting time here equal to 1. So we cannot select this one. So we will just remove this from here because we cannot select this if we selected our 1, 2, right? And after that we have here 2, 4 and we can see starting time of this interval is equal to our ending time. So we can obviously select this. This will not overlap. So after that we will just select this and there is also a choice for not selecting this. So select and not select. So if we are selecting this, the profit will be equal to, so here it have a profit of 4. So we will have profit of 8 and our index will be out of bounds. So index will be equal to n, then we will return 0, right? Because then the final answer will be equal to 8 plus 0, then 8. So here we are getting answer 8 after selecting first and last interval. And if we are not selecting this, still the answer will be 4 and we will be out of bound. So we will also return 0. So answer is here 4 and here is our answer 8. Here it is 8, here it is 4, and let us check this condition if we are not selecting our previous one. So if we are not selecting our first, then either we can select this or not select this. So currently we are at here, so we will not consider this. So here the same condition, we will select it or we will not select this. So there are two conditions, and if we are selecting this, the maximum answer will be 7, and the next interval will be 2 to 4. So if we are selecting an interval from 1 to 5, then we cannot select from 2 to 4 because this will overlap. So currently the answer will be 7 for this. Okay, here it is 7. And if we are not selecting this, then the last interval will be from 2 to 4. And there is these two conditions from here, select and not select. So if we are selecting, the answer will be 4 and we are out of bound. So here the final answer will be 4 and if we are not selecting, final answer will be 0. So what is the maximum answer? You can see this. And the total guesses we are getting is 2 to the power n. So time complexity will be also 2 to the power n. And how can we optimize it? We can use DP to optimize this approach. So what can we do? You can I think you can see here this case is repeating when we are here at 2 to 4 and the maximum answer will be 4, and here also we are at 2 to 4 and the maximum answer we are getting from this approach, this interval will be 4, right? So we are getting here 4. So what we have to do, this case are repeating, so we can just store this. First of all, we have to find this and we will just store that answer in our DP array. So after that, when we are checking, we will just return this. And I think there is no more repeating case. Yeah, so we can just do this algorithm and we have to create a DP. First of all, I will just show you simple recursive solution and that have a time complexity 2 to the power n exponential, and then we will optimize it using DP. So first of all, we will start from our zero index. Okay, I will just write a recursive function that will turn us our final answer. That have what do we need how many things do we need? First of all, this array we need our recursive function and the index. So first of all, we are at here and then here, so we will also need index. We will start from 0 and intervals, and I think we should also pass n so that we can specify this condition that if our index is equal to n, then we will just return 0. So that will be our base case, right? So I will just create a static int recursive function index array. Okay, first of all, we also have to sort our intervals array in according to our starting time or ending time. So what we are doing here, first of all, we are checking, first of all, we are getting some ending index of our selected interval, and what we are checking for our next interval, that starting time of any interval should be less than or equal to this ending time. So we already have our ending time and we are checking for starting time, so that's why we have to sort according to our starting time. So arrays dot sort, and there is also some different approach that I will show you if we are sorting according to our ending time. So here we have to sort according to our start time, and I will just pass here a lambda function that will return us. Okay, I will just specify some conditions here. So if our starting time, I'll just call it ARR. So if our starting time is not equal, then we will sort according to our starting time. And if our starting time is equal, then we will sort according to our end time. So that will be at first index. Okay. And this intervals array is now sorted according to our starting time. Yeah, it's something like this. And after that, we have to define this recursive function. Here we also have n. So first of all, our base case. So every time when you are writing some recursive function, first of all mention the base case. So what will be the base case? So if our index is equal to n, then we have to return 0, like in this case. And also every time we have to return 0, right? Obviously. So if our index is greater than equal to n, then we have to return 0. And after that, what we have to do now, we have two conditions. Either we have to select this particular index interval, or we don't have to select this. So first of all, if we are not selecting this, then we just have to move ahead, right? So that will be our simple case. So if we not select, then we just have to find the answer from we just have to move ahead and find the answer. So index plus 1 and array and n. And if we are selecting it, select, and what we have to do in select. So first of all, we have to okay, this is here 4. So first of all, if we are selecting this, here it is select, and if we are selecting this one, then we also have to add the what is the profit, right? So we also have to add the profit of this particular interval and the next immediate interval, which have a starting time greater than the ending time, right? So first of all, we have to add the profit of this particular interval. So profit of this interval will be ARR index, and the profit is on second index plus, and now we have to find what is the index of this particular interval that have a starting time. So we have 1, 2, and after that we have 2, 4. So this have a some different index, and this index we have. So we have index as index of this interval, but we don't know the index of this interval that have starting time greater than or equal to ending time of our index interval. So how can we find this index? So how can we find index of this interval? So first of all, either we can just iterate and get the index, or you can also use binary search, but for simplicity we will just iterate. So we will just get the next index, and I will just use here a helper function, find the next. And what we will do here, so we have to pass this value because this is the ending time, and we have to find some interval that have the minimum value of starting time greater than or equal to ending time, right? So I will just pass here index ending time, and I will also pass array, and I can also pass n. So static, this will return integer, find the next, that is the previous ending time, and there is also n. So how can we find it? So I will just linearly iterate over our array. So this is our index, and we are here at we are here. So I will just pass this index also that we have to find next, right? So our index value is this, and we have to start checking from this value, right? So I also have to specify this I, and this is our previous end, and this is okay. So what we have to do, we have to start checking from I while I is less than n. Then I have to check if any particular interval at ith index have a starting time greater than equal to previous end. So that is the thing we have to do. We have to check starting time of every index. That is here. First of all, we will check the starting time of this. That is here 1, and that 1 is not greater than previous end. So our previous end was 2, but it is here 1. So 1 is not greater than 2. So we will just skip this one. And if it is greater, so else we have to skip. And if it is greater, so in case if it is greater, so when we are at here, so we are now at here 2, 4. So this is here 2, 4. So when we are checking for this, the starting time is here 2, and the previous end was also 2. So if it is greater than equal to, so our starting time is greater than equal to, so it is not overlapping, and then we can just return this I. Else we will also return this I, because at last we will just return n. So we don't have to return here. I will just break. and at last we will just return this I, even if the I is equal to n. So if the I is equal to n, then what we have to do? So if I is equal to n, then we will just fall in this case. So it will return us 0, obviously. And here we have to now use recursive function of this next index, and we have to also pass array and n. So that is it. So now focus on this function, and at last we have to return math.max of select and not select. That's it. So that is our whole algorithm. So first of all, focus on this function, and let me just tell you what we are doing here. And the answer is correct, but this is not optimized. We also have to optimize it. So first of all, what we are doing here? So first of all, we are at this index, so 1 2, and we are checking. If we are not selecting, then we are finding the answer from our next index. That means we are moving here, and there we will also have the same condition, either we are selecting or not selecting, and the maximum answer from this side can be 7, right? Because you can see 7 4 and 0, so the maximum answer can be 7 if we are not selecting it, and not selecting, and if we are selecting this 1 5, right? So we are returning here, from here we are returning 7, and after that if we have to select this one, so let me just clear it. There is a lot of math now. So if we have to select this one, so if we have to select this interval, then first of all, what will happen? So first of all, we will just get the profit from this interval because we are selecting it. So the profit is here 4, and here you can see if we are selecting this, then first of all we are adding the profit that is at 2th index. And after selecting this, what can we do? What next interval we can select? So first of all, we have to find what is the next interval that we can select. The next interval is this 1 5, but we cannot select this because the starting time of this interval is smaller than the previous ending time. That is the condition specified here. Starting time of this interval should be greater than ending time of this interval, right? So, but here the starting time is lesser than ending time, so we cannot just select this interval. So what we will do, we are just linearly iterating using this find next function, and we are just getting the current immediate next after that, after iterating, we are just getting the next immediate interval that have a starting time greater than or equal to our ending time. So we are just finding the next interval that we have to select, and we are doing a recursive function to do the same for this. So we are here at 2 4, and we are just doing the recursive function, that means select and not select. We just don't have to select this interval, right? Because it can have ending time obviously very large. So suppose it have ending time 1000, and there are more elements here that we can select which have a higher profit, right? So we don't have to select this one, and we can select next element which have a higher profit. So we also have to do here recursive function that either we can select this or we don't have to select this. So we will just find the maximum answer from this recursive function, that either the maximum answer can be from selecting this or not selecting this. So we will just get the result from our recursive function, and we are adding that profit to here. And at last we have to find the maximum profit from selecting or not selecting our this value 1 2. So that's it about this, and this will just give TLE. I don't want to submit it, but let me just show you. Okay, you can see here it is just giving TLE at 10 because here we have an exponential time. So the time complexity is here 2 to the power n, and how can we optimize it? You can see there are multiple cases that are repeating here. So here it is 2 to 4. So this case is exactly same as this. So this will return us 4, and we are adding previous 4 to this. So that is obviously repeating case, and we will just create a DP here. So I will just pass here this DP that have a size n, and we also have to specify here if, okay, we also have to fill that DP with -1 value. I think the profit cannot be 0. Okay, the profit cannot be 0, so we don't have to fill that with -1. We just have to check with 0. So if DP of I is not equal to 0, DP of index, then we will just return that value. And if it is equal to 0, then we will just calculate, and at last we will just fill our DP value equal to. So that's it. We just optimize it using two lines, so this line and this line. Okay, we also have to specify here our DP. including it in our parameters, and at last here. That's it. So we just optimize it from our what is the time complexity from 2 to the power n to our n square, and we are also using here space complexity as n, and the time complexity is n square, and it will get accepted because the constraint are 10 to the power 4. Okay, what is the problem here? We also have to pass here, right? So in function call you have to pass like this, and when we are defining our function we have to write like this. You already know this thing, right? So now this solution should get accepted, and it is. So how can you further optimize it to n log n? And you can see here what we are doing here. So we are linearly iterating. So what is the optimization for linear iteration? That is here binary search. So linear search, we are doing here a linear search that have that element that have a starting time greater than equal to ending time. We can just optimize it using binary search. So I will just not show you, and I will just show you different approach of how we can sort it according to our ending time. So if we are sorting according to our ending time, let me just show you. So if you want to stop this video, you can just leave now, and I will just paste the solution in our DSA repository. But I will just show you the next alternative approach of solution solving this problem. So we have interval 1 2, and we have 1 5, and we have 2 4. So if we are sorting according to our ending time, so this will look like ending time. So 1 2, and then the next element will be 2 4, and the next element will be 1 5. So if we are sorting according to our ending time, then what can we do? First of all, we have to do the exact same thing, that we have to select or not select some particular interval, and we have to find either there is some next non overlapping interval or not. So we have, if we are sorting according to our end time, then what we have to do? If we are selecting some interval, then we know the next interval should not necessarily be in the have a starting time greater than or equal to end time of this. So what can we do? We cannot just select from starting. We have to select from end. And what we will do? We will select some interval from end. So we are selecting some interval from 1 to 5, and then what we will check? We will check for all previous interval that have ending time. So we also have to check ending time that have ending time less than or equal to starting time of this current interval. So we already have starting time of this interval, then we have to check the ending time of our previous interval. So here it have a starting time as 1, and we have to check all the intervals that have a ending time less than or equal to 1. So there is no interval, and then this will be 5. So its profit is 7, right? So here it will have a profit of 7, and if we are not selecting this particular interval, then we will just move here and we will just do the same thing. So if we are selecting this interval, then current answer will be 4 plus the previous interval that have ending time. So we have to check for ending time. We already sorted according to our ending time. So we also have to check the ending time that have ending time less than or equal to starting time of this, because then they will not overlap. So if the starting time of this is ending time of this is less than equal to, so if it is less than equal to starting time of our selected interval, so starting time is this, and it is from here to here. So if the starting time of our selected interval is greater, or we can say the ending time is smaller of previous interval, so then we can select. So if I will just sort it according to our ending time. So if ending time is not equal, if ending time is not equal to each other, then we are sorting according to ending time, else from starting time. So I will just use the same DP here. Just we have to start checking from our last interval, last index, and minus 1. And the base case will be if index is less than equal to 0, then we will return 0. Because every time we have to decrease our index, right? So we are starting from last index, and every time we have to decrease our index. So every time we have to decrease our index, and here I will also decrease this. Okay, and next if we are selecting it, then yeah, everything is fine, right? So we have to now change our this find next function, because now we are moving from last to first. So now we have to say I should be greater than 0 and greater than equal to 0, and if I is less than 0, then we will just fall in this case and we will return 0. Okay, so if our ith value, so first of all we will check this if our we have some particular ith interval, and if it have a ending time, so now we have to check ending time. Ending time is, and here we have to pass now previous start, and here we have to pass previous start value, that is here 0. Okay, so we are passing our previous starting point, that is here 2, and every time but we are checking for all the intervals, so we are checking ending time. If their ending time is less than equal to previous start time, so we are checking their ending time if it is less than equal to previous start time. So our previous start time is here, and we are checking for all the intervals that their ending time should be less than equal to our starting time. Ending time should be less than equal to starting time, and if we found anyone, then we will just break and return I, and every time we have to decrease I. Right, so that's it. I think that is the simple optimization that we have to do in order to change our algorithm. And I think we are missing to something here. Let me just check here. So if it is not according to our if our ending time is not equal to each other, then we will sort according to ending time and pass here end and the last index. If index is less than 0, then we will return 0. If there is some value, then we will return that. If we don't have to select, then we will just check for our previous index, and we don't need n here, right? You can see. And what is our next index? So next index will start from index -1, and we are passing here starting value of this current value, current index, current interval. And if we are selecting this, then we are adding the profit plus next index. Okay, that's fine. And I think the problem is can be here I and previous start, while I is greater than 0. Ending time should be less than previous start. So right, ending time should be less than or equal to our previous start. Then we will just break, else we have to decrease our I. So what is the problem here? I don't know what can be the problem. Okay, I think I should not have to make you wait anymore. So I will just pause and find the problem. Okay, there was a silly mistake. We just wrote here index should be less than equal to 0. So that was the problem. If we are at 0th index, then we have to select the 0th, either we have to select or not select the 0th index in interval. But here we are just returning 0 when we are at 0. So at 0 index. So we don't have to do it like this. So if the index is less than 0, if the index is negative, if the index is out of bound, only then we have to return our 0. Then that is it. So this is the same algorithm, and we are sorting from end time, and we are also starting from our end interval, last interval. So that is it about today, everyone. If this video is helpful, go hit the like button and also subscribe to our channel. And if you got this algorithm right, so then hit the like video and must share this video, right? So thank you for watching.